Hello and welcome to the Mindset tutorial series. This video is an example of a design exploration study using Mindset. In it, we will go over how various visualizations and machine learning options found within Mindset can be used to post-process the results of simulation data. The data we're using was donated to the machine learning community by NASA and comes from the Global Climate Modeling exercise. The parameters of 540 simulation runs were recorded, along with whether the simulation succeeded or not, shown as the outcome variable. We can see that most of the runs succeeded, but 46 of them failed, which is what the zero outcome stands for. Let's use Mindset to see what we can learn about what might have affected this outcome. The first thing to do is to drag the outcome variable over here to analyze it. This visualization shows us which among the input parameters have the greatest influence on the outcome in a cumulative manner. We can see that parameter 2 seems to be the biggest influencer, that parameter 1 adds a little more ability to predict the outcome, and so on. To take a closer look at exactly how that works, we can employ parallel coordinates. By highlighting the zero outcome, we can immediately see the pattern. It's the high values in both parameter 1 and 2, and low values in parameter 6 that seem to be the culprit. Let's go back and try other options. The what-if visualizer looks at each variable independently and calculates the distribution of the target variable, in our case outcome, across the range of values. This is how it finds the breakpoints that divides the parameter space into the successful or not so successful groups. So, for parameter 1, the breakpoint is at 0.561, and for parameter 2 at 0.48. What-if visualizer also allows us to play hypothetical games and see what are the chances of success when given individual parameter ranges. Say, indeed, that parameter 1 and 2 are high and 6 is low. Looks like those settings make the simulation fail in about half of the cases. Next step, let's see what decision tree shows us. The decision tree also divides the parameter space according to the outcome variable by splitting up the tree in such a way that it maximizes the difference among the branches. So again, we can see how parameters 1 and 2 split the input into great outcomes and not so great outcomes, and keep doing that at each branch. Eventually, we can select a good node as an example of a best practice in a simulation setting, and a bad node as a value range to be avoided. We can select a set of rules from the decision tree by clicking on the header of a node. These rules can then be fed back to the simulation process as a way to either avoid bad outcomes or focus on the good ones.